Hi everyone, and welcome to our module on database queries. And we've got a lot to cover, so let's get right into it. So you can't talk about database queries without talking about SQL. So SQL is a structured query language. It was invented in 1974 by Donald Chamberlain and Raymond Boyce. They were working at the IBM T.J. Watson Research Center at the time, and they met E.F. Codd. And you might remember from last time that Codd is the computer scientist who developed the idea of a relational database. So they met E.F. Codd while working at IBM, and they took upon themselves the challenge of implementing a query language for the relational database. Now, Codd, in his paper where he spelled out the relational database, talked about two concepts, a relational algebra and a relational calculus. Both of these are notational. The idea is, can we identify a selection of data given different data tables using set notation and using formal logic? Using set notation, that was called Codd's relational algebra. Using formal logic, that was called Codd's relational calculus. Both of them were really precise, very mathematical in their orientation for starting with a collection of data tables and then pulling out a selection of data from a combination of those tables, right? But Chamberlain and Boyce, their purpose was to try and implement that without having to use all of the mathematical notation. So we'll come back to that in just a second. But first, let's talk about how do you pronounce this thing. So some people say SQL, other people say SQL. And that debate goes back a long time. So when Chamberlain and Boyce first created software to query a relational database, they called it SQL. But then they had to deal with a copyright claim from a British company that already had software named SQL. And it was completely unrelated, but they had to change the name. So they changed the name of their software from SQL to SQL. But today you'll hear people say SQL and some people say SQL. Both are fine. So let's talk about the philosophical underpinning of SQL. So it's based on set theory, and it's based on the idea of set theory that any mathematical expression you can create with set theory can be expressed in plain language. So consider this set, I'll call it A. These are the holidays in the United States when the banks are closed. So we've got New Year's Day, MLK Day, and you can see the list here. Let's also consider set B from the United Kingdom of bank holidays. So we have a few, Boxing Day, summer bank holiday, things like that we don't have in the United States. Now, we have set A and we have set B, and we can consider set operators to combine these two sets in some way. So maybe the simplest operator here is the intersection, denoted with this upside down U. And so the intersection is all elements that exist in both A and B. And so when you look at the UK bank holidays and the US bank holidays, it's just New Year's Day and Christmas that the two countries have in common. Now, that is a formal mathematical operation, but it has a semantic underpinning, right? So it's and, right? A and B. What are all the elements that exist in A and B? And so that is a common characteristic of everything in set theory, that even though you can write it out in math, you can express it in plain language. And the purpose of SQL is to express a database query first in set theory, but then translating that set theory to plain English. And that's why people like SQL, find it intuitive, because instead of these symbols like an upside down U, we would literally write the word and. Also, SQL is totally universal. It is maybe the most universal of all programming languages. It is designed to work with many different DBMSs. So SQL works with SQLite, it works with MySQL, it works with Postgres. but it also works with the proprietary DBMSs like SQL Server and Oracle. So if you know SQL, you'll be able to work in all of those platforms. The other thing that makes SQL so universal is that all of these environments for working with data, like Python, like R, but also C, Java, JavaScript, they all have interfaces that read SQL queries and process it internally to Python or something like that. And so no matter what environment you're working in, no matter what DBMS you're working with, once you know SQL, you know how to work with a relational database. So SQL has been in continuous use since the 1980s, and it's just becoming more important. It's hard to find a job posting in data science these days that doesn't ask for SQL. And the reason for that is because of its universality, because of how elegant the language is and how semantic it is. Now, different DBMSs like MySQL and Postgres, they'll use slightly different versions of SQL. There is a universal SQL standard that is maintained by nonprofit organizations that facilitate consensus standards, but there are certain things that say MySQL doesn't implement in the full SQL standard. For example, MySQL can't do a full join. Postgres, among all the DBMSs, comes the closest to implementing all of SQL. That said, the difference between one DBMS and the next in terms of how they implement SQL, the differences tend to be minor, and you can almost always do the same work no matter what the implementation. Now, there are some situations in which you're not going to use SQL. That is, if the database is not a relational model, then there's no reason to use SQL. So a NoSQL database, like a document store that we talked about last week, it can have a much more flexible schema. It can store records in one big table, or it can store records in as many different schemas going record to record. There's no requirement of consistency. But the other thing is, record by record, you can shard those. So it means we can take different records and store them in different places across a distributed system. And that's a big advantage. The point is, if you don't have tables, if you have something like a giant collection of JSON documents, then there's very little gained by using SQL. And so that's why the non-relational databases are often called NoSQL, because they don't require the SQL language. A better name for these would be non-relational databases, but they're always called NoSQL. So both SQL and NoSQL query languages use CRUD operations. That's create, read, update, and delete. So there's a way to create new observations and to put those in the database. There's a way to read or load the data. There's a way to edit, revise, or update the data. And then there's a way to remove or delete the data. This is a table that shows the CRUD operations using three things that we've talked about. So going back to modules 3 and 4, we were talking a lot about the request library in Python for accessing an API. When using an API to read data, we're just saying get data from the API. But we could also push data to the API to be stored in the external server with put or post. We can edit it with patch, and we can delete data with delete if we have the right permissions. Most APIs won't allow us to do that. With SQL, we have the exact same operations with insert, select, update, and delete, and we'll talk about those. And then with MongoDB, we have insert, find, update, and remove. Now, there are examples in the notebook for this week about how to do all of this, more so than we can cover in a video. Data scientists mostly use read operations. So it's good to know about create, update, and delete. It's going to be essential to know if you are building your own original database. But if you're just trying to get data to analyze with machine learning or something like that, read operations are going to take up most of your time. Now, before we get into actually running SQL, let's talk about some style points with SQL. So the least readable way to write a valid SQL query is like this. So all on one line. In this case, it overflows to 2 lines just because it's long. But all in one line, no capitalization, no indentation. And this is valid. This will get me what I want, but it's not good looking. And so let's talk about style. So one stylistic choice is to find the clauses. Now, clauses are these functions that are internal to SQL. So select, from, inner join, on, where, order by. These are all clauses. They all do different things that we're going to talk about in these videos. For all of the clauses, one stylistic choice is to write them in all caps. So you can see here, there's select and from and inner join, and they're in all caps. Another stylistic choice is to put clauses that are considered distinct from previous clauses on new lines. Now, the one exception is from. From is closely related to select. Now, we're going to talk about what these things are, but I just want you to see the format here. So here we can see select and from right here on the same line. But all of the other clauses are on their own line. And hopefully you can see at this point that the query is beginning to get much easier to read and wrap your head around. Now, one more stylistic point is indentation. So if there is a clause that's considered to be an elaboration upon a previous clause, it's common to indent it. So for select right here, we have the columns that we're selecting. And again, we're going to talk about what that means in a few minutes. And then from, and then inner join. On is considered to be an elaboration of inner join, so that gets indented. So writing columns like this, writing queries like this is a good idea. And I encourage you to develop good habits, because when you start writing your queries like this, it's going to make your code more readable, both for other people, but more importantly for you, right? You're going to write code, you're going to save it, you're going to stop working for the day, you're going to come back to it the next day, and you're going to have to spend time trying to remember what you did. Writing your code in a readable way is going to be kind to yourself. The other thing is we use single quotes, not double quotes, when working in SQL code. The reason for that is the way we input queries, SQL queries into Python, is going to use the Pythonic triple quote. So here we have 3 double quotes to begin and 3 double quotes to end. This allows us to write a string that goes on for many lines, and that allows us to write these stylistic things. But because we're using double quotes, to distinguish from the quotes that begin and end a string, we should use single quotes inside.